Good morning, everybody. This tutorial is called Rapid OpenStack Deployment for Novices and Experts Alike. Please do note that this is a double slot. So this is a tutorial. This is twice the length of a usual conference talk. It's scheduled until 12:20. I cannot guarantee that we're going to have a break at precisely the right moment for you to move to a different talk. So please do keep track of time yourselves. If you do want to switch to a different talk in the second half of this tutorial, please feel free to make your way out whenever convenient. That being said, I'm happy for anyone who stays till the end. For those of you who don't know me, this question is entirely appropriate. You may be wondering who the heck I am. My name is Florian Haas. I am one of the co-founders and the principal consultant at Hastexo. We are a professional services company with people in Europe, South America, and India, specializing in professional services for open source technology related to distributed storage, high availability, and open source cloud. And as far as the open source cloud part is concerned, we're really pretty much an OpenStack company. We don't do much CloudStack or OpenNebula or Eucalyptus. We're very much an OpenStack company. There are two links here. One is my sort of corporate bio, but you can also find me on Google+. If you just search for Florian Haas, I will likely be your first hit there. There's my personal email address. I'm one of those strange holdouts that does not maintain a personal Twitter presence, but my company does, so find us there. And if you're interested in more of the training-related stuff that we're doing that is sort of similar to this kind of tutorial, then you can also check out academy.hastexo.com. What's the problem?
There's too much light on the slides. I can't see where those lights are in this room.
All right, let's just get going with the tutorial.
Sorry.
Thank you. OK, a few little bits and pieces of service. You can snap this QR code. It will take you to a Google+ event. For those of you who are more familiar asking questions or making comments in writing, please do it here. I have the event open on my phone, and I'll be happy to answer questions that we get that way. For those of you that can, sorry, I'll bring this up again in just a moment. For those of you who cannot tell the difference between the color of my lanyard and the color of the OpenStack logo, if you're red-green confused, I have good news for you because the slides only use red and blue. OK, so back to that. Feel free to snap the QR code for that and check in on that event. And feel free to ask questions that way or leave me your comments. I'll be happy to answer them during the tutorial if possible or later on if it's something that kicks off a longer discussion. OK, everyone got that? Everyone that wanted to do it? OK. I have one house rule here. I failed to lobby for this to actually become a conference rule, but I'm going to make it a house rule in my tutorial. If your phone audibly goes off in my tutorial, that means you owe me a drink. Very simple. Not necessarily this type of drink, but a drink of my choice. All right. So with that out of the way, let's do a humming poll. Humming poll is a wonderful and anonymous way of polling people. So for those of you, and what I do is I ask a question, and the more vigorously you assent, the louder you hum. OK? So let's try that. OK? We are at linux.conf.au 2014. Wonderful. Pigs can fly? Great. Well, not so much. Yeah, that's how it works. OK. Please hum if the following statement is true for you. I am a complete OpenStack novice and have never used OpenStack neither in production nor in a testing environment. OK. Please hum if the following statement is true for you. I have deployed OpenStack in production or in a testing environment. It's actually about equal. That's cool. Again, same rules. I have used and deployed Puppet in production. I have no clue what Puppet is. Oh, OK. Interesting. OK. What is that? All right, great. So I have a rough idea on what everyone's prior knowledge is, which is we have a very, very diverse group, which is going to make this very interesting. Those are the two key technologies that we're going to be covering here, OpenStack and Puppet. And I'm going to try and do my best to explain as much as I can in terms of basics for those technologies. I can't provide you with like a full-on OpenStack or Puppet crash course, but I'll try to do what I can. Okay. For those of you who are already familiar with OpenStack, this will just be a refresher. For those who aren't, this will be a reasonable overview over the architecture of OpenStack. As I'm sure most of you are aware, OpenStack is an open source infrastructure as a service platform. It is pretty much 100% written in Python. It is pretty much 100% under the ASL 2.0 license. Oh, by the way, for those of you snapping pictures of slides, all those slides are available on the web, and I'll be sharing QR codes for those later on. So no need to snap pictures here. IaaS platform, written in Python, ASL 2.0 licensed, originally came out of a collaboration between NASA and Rackspace that started in 2010. Right now, it is arguably the fastest growing and largest community-driven cloud platform project out there. And it is not one monolithic big blob. It consists of several building blocks. And all those building blocks are up here behind me. We have a central identity component, OpenStack Identity Service, codenamed Keystone. All OpenStack services have like an official marketing type name and a code name that we use like for all the binaries that we write, et cetera, et cetera. So at the bottom of the slide here, OpenStack Identity, Keystone, maintains basically a database for user authentication, authorization, and access control, as you would expect, but also maintains a service catalog. That is to say, by querying a Keystone service, any OpenStack client can find out where all of the other services are, which is nice because you have just a single entry point into OpenStack. We then have OpenStack Compute, codenamed Nova. This is the compute infrastructure that actually interfaces with hypervisors on virtualization hosts. And OpenStack Nova supports a variety of hypervisors. Most people will be using libvirt and KVM. That's also what we're going to be using in this tutorial. Also supported are Xen through various APIs, VMware, Hyper-V, and also a bunch of container-based virtualization solutions like LXC, and also we're getting Docker support, which is cool. Virtual machines need virtual machine images. Those virtual machine images are stored in the OpenStack image service, codenamed Glance, which we're also going to deploy as part of the tutorial. Optionally, those images may be stored in the OpenStack object storage service, codenamed Swift, although there are other backends that the image service supports as well. So the object storage service is a RESTful object store, relatively similar in design and use to Amazon S3, for those of you who are familiar with that. We also can provide virtual machines with persistent block storage, codenamed Cinder. And we also have a network management component, OpenStack Neutron, which does all sorts of neat things about network virtualization, network segmentation, switching, routing, firewall as a service, interaction with OpenFlow hardware, all sorts of good things. And then we have actually a set of unified user interfaces that we can use to interact with the cloud. One of those is the web-based OpenStack dashboard, codenamed Horizon, but that's not the only one. We also have a set of command line tools, so everything that we do in OpenStack is easily scriptable, and all of the APIs to the OpenStack services, or management APIs to the OpenStack services, are themselves RESTful, HTTP, HTTPS-based, and primarily bounced JSON objects around. And on top of that, we have a number of client toolkits and SDKs that we can use to interact with an OpenStack cloud programmatically, whether that is through Python or Java or scripting something with curl, if you're into pain. There's a number of these unified APIs that we have. Actually, that OpenStack architecture, as shown here, is slightly oversimplified. This is a good overview of the OpenStack architecture as of the previous OpenStack release, OpenStack Grizzly, which was released in April of this year. In the Havana release, OpenStack 2013-2, which was released in October, we have two additional components, namely components for orchestration. Those of you familiar with things like AWS CloudFormation will find that familiar. And we also have, and in OpenStack we call that heat, because heat is something that makes clouds rise. And then we have a metering component that we can also use for monitoring and billing purposes. And that's called ceilometer, because a ceilometer is a meteorological device that ostensibly measures cloud coverage. In fact, that's not really true. It mentions basically the bottom of the cloud, measures the bottom of the cloud ceiling, but oh well, close enough. So that's a rough overview over the OpenStack architecture. And that lends itself to the concept of OpenStack node roles. So you will be deploying this architecture on a bunch of hardware normally. And from that, it follows that specific pieces of your hardware, specific nodes in your environment will play certain roles. And these roles are essentially logical, atomic, and composable classes of nodes in an OpenStack cloud. Now, what do I mean by that? They are logical because they're not necessarily tied to specific qualities of your physical hardware. They are atomic because these roles are normally not broken down further. And they are composable because it is absolutely conceivable, and in fact very common, for a specific node, for a specific piece of hardware, to have several of those roles at the same time. So that's what I mean by this concept of OpenStack node roles. And let's take a look at what those might be. So for example, you will have an infrastructure node. This is the stuff that runs a database, and we use a relational database as a persistent data backend for various OpenStack services. By default, this is MySQL, but you can essentially use anything that SQL Alchemy supports. So for example, you might be running Postgres as your RDBMS backend. And we also use a message queuing service for various OpenStack services to communicate with each other. And by default, this is RabbitMQ, but we also support Cupid. We have some support for ZeroMQ, but we need a message queuing server. And we need a node, we need a bit of hardware that runs our database and our message queue server. That's our infrastructure node. We then have an authentication. Oh, by the way, I forgot to mention this earlier. Questions? Please, yes, anytime. Just so that's clear. The authentication node runs the OpenStack Identity Service, Keystone. And the OpenStack Identity Service provides not only the classic AAA, user authentication, authorization, access control, but also a service catalog, essentially a list of all of the API endpoints that we have in our OpenStack cloud. The services available, the service that we choose to expose in this OpenStack cloud, and the nodes or the addresses where we can find them. Then we have an API node. That's the node that actually hosts those RESTful API endpoints to OpenStack services. One thing that's nice about the OpenStack services is API services is that it's an underlying design criterion for all of these services to be locally stateless. And that makes them automatically horizontally scalable. We can have them on as many nodes as we want. We can put load balancers in front of them, and we can interact with them that way. And that's kind of cool. So we might very well have not one, but several of these API nodes, or we might spread out services across multiple, whatever. Then we have the controller node. A controller node basically provides scheduling and registration services internal to OpenStack. Now, why is this distinct from the API node? Any ideas? Why would we put that on two different hosts? What is that? Exactly. So the standard answer whenever you're being asked a tutorial question like that is always one of two. It's either security or performance, right? In this case, it's mostly security. You might want to typically expose your API endpoints on a public network. whereas you might not necessarily want to do that with your controller node. So therefore, splitting those and having this node, the API node, with one leg in the public network, and this node, the controller node, just basically constrained to your controlled management network, generally tends to be a good idea.
Florian,
Yes?
do that just with firewall higher up, or because this is just on different ports and the like?
So the
Another interface on
yeah.
the controller?
Okay, so the question was, could you not do that with firewalling? The concern here is more like, what if someone managed to compromise the API node through a vulnerability in the API services? Or, for example, in the web server that exposes these API services, if they compromise that node, do you want them to then be on the same node that's also your controller, where they can potentially do other things, or do you want to make it a little harder for them because they now need to also break into your controller node? That's pretty much the only concern there, or that's one of the major concerns there. Then we have a network node, which provides network connectivity. Well, it manages network connectivity within the cloud and also provides network connectivity to public networks. Normally, you would want to have your virtualization workloads, your virtual machines, accessible through the public network, or you will want them to access the public internet in some shape or form, and it is your network node that does that for you. And then, of course, we have compute nodes, typically not one, but several of them, that actually host and run virtual machines. They interact with hypervisor services on specific nodes, and they actually run your VMs. And then we have a few others, such as, for example, we might have a block storage node that provides or manages the provision of persistent block storage to your guests. We might have a separate dashboard node, which provides a unified user interface to your cloud administrators via the OpenStack dashboard, aka Horizon. It is not uncommon for this node to be composed with the API node role on the same box, because you basically expose all of that on the public network. And we also might have a metering node for Ceilometer to collect metering data from a unified event stream. And we might have an orchestration node that runs an orchestration engine for pretty much arbitrarily complex guest workloads, which is really kind of cool when you see it in action. How does this map to our tutorial architecture? Now, again, I'll just briefly reiterate. I'm going to run through the steps that I want to show here in this tutorial here on my setup, and you are free to follow along if you choose to do so. If you don't want to do that and you instead want to take the VMs home and run this in your own office or home or wherever, then you're certainly free to do that as well. But as far as the architecture is concerned, we have one node that actually holds a great number of these roles. We call it Alice, and Alice is going to work as our infrastructure node, authentication node, API node, controller node, storage node, dashboard node, and we could also slap the metering and orchestration on Alice if we wanted to. I'm not sure if we're going to get to that time-wise, but it will be very easy to do for you. Then we have a node named Bob. Bob is going to be our compute node. So Bob's going to be the thing where we're actually firing up virtual machines. And then we have Charlie, that's going to be our network node. Some of you may have noticed, those of you who have already fired up those virtual machines, Charlie is the only one that has an additional network interface configured. You will also notice that that network interface actually has an RFC 1918 address, because I didn't want to wreck your network setups and just put a random public IP address there. But in a production setup, that would be exposed to your public network. Okay, so you just have to bear with me that for the time being, we're going to define 192.168.144.0/24 as a public, quote-unquote, public network, which Charlie is going to be connected to. And then, because we want to do all of this with Puppet, we have a Puppet master node, which, because I'm ridiculously creative, I named Puppet. And all those nodes are Ubuntu 12.04.3 LTS nodes. The OpenStack nodes are essentially completely bare except for the plain Ubuntu install and a Puppet agent. The Puppet node is an Ubuntu install with pre-populated Puppet modules and /etc Puppet modules, and also a pre-populated app-cacher-ng proxy server such that we can actually install packages off of this box without hitting the network. Where do these come from? Where do these Puppet modules that I mentioned come from? There is a project called StackForge. I'm not going to get into this in too much detail, but OpenStack has a really awesome continuous integration and continuous development, continuous deployment infrastructure that we use for the OpenStack project proper, that a variety of companies have donated ridiculous amounts of hardware to, where we're running tens of thousands of tests every day on the OpenStack code base, which is wonderful, but we wanted to make sure, or specifically the OpenStack CI team wanted to make sure that that's not only available to the OpenStack project proper, but also to a variety of other OpenStack related projects, and that platform we called StackForge. And on StackForge, you're going to find a collection of Puppet modules for OpenStack, for most of the OpenStack services, and also a lot of other stuff that is OpenStack related but not related to Puppet. That's also hosted on StackForge. So that is where you will find most of the Puppet modules that we're going to be using today, except for one thing that we call Kickstack, which is a really thin wrapper around these Puppet modules that you will find on StackForge. Essentially, it just maps the resources that can be defined using the StackForge Puppet modules to those node roles that I just described, and then you can assign those node roles either from your Puppet manifests or from a Puppet external node classifier, an ENC. And we are actually going to be doing it with an ENC, namely the Puppet dashboard, which means that we can actually assign those classes with a few clicks on a web interface. But again, that's not a requirement. You can do that with Puppet Enterprise. You can do it with the Foreman. You can write your own ENC if you so choose. And you can also manage this stuff from standard Puppet manifest files, if you're familiar with those. Wait a minute. Oh, never mind. Oh, and we should have a Puppet dashboard here. Let's see. Is that there's my Puppet dashboard. If you set up, so for those of you that are actually following along, if you set up the virtual networks as outlined in the message that I posted to chat yesterday, which is that you configured your VBoxNet 0 to the 192.168.122.100 network, then you should be able to connect to this address now, HTTP 192.168.122.100 port 3000, and what you should see is an empty Puppet dashboard, a Puppet dashboard with no nodes that have checked in. If you did not set networks up that way, then you'll now have to set up, NAT for your, port forwarding for your NAT network on that virtual box, which you might or might not like to do. So it would be great if you actually set it up this way so you can access this directly.
Florian, it's worth noting that you didn't specify the put an IP address on the VBoxNet 0, so we can't get to it unless we have an IP address manually with the interface.
Thank you. So the IP, well, no, actually you can do that in the VirtualBox configuration. Yeah. Okay, so the question was, how do we actually get there? Considering that VirtualBox by default doesn't set an IP address or whatever for that network. So if you actually edit your network configuration in your VirtualBox manager for the VBoxNet 0, VBoxNet 1, and VBoxNet 2 networks, what did you do? You just put 0.1, yeah, okay, for the IP address of said host-only network. So you should have your host configured to 192.168.122.1 in a Class C subnet, and then you should be able to do this here.
Which machine is that for?
What is that?
Which machine is that for?
No. That's so setting the network configuration for your host-only networks is something that you do in the VirtualBox Manager. It's not machine specific, but in the Virtual Machine Manager, you go to File, Preferences, Network, and then you edit your network connections that way. Oh, and by the way, I'm sorry, I cannot assume any responsibility for some sort of a local firewall that you may be running that may be blocking your access there. So please, if you do need to run into something like that, you're going to have to fix it yourself. Okay, but this is generally what we would expect to see here. You should see no nodes in there, so the dashboard should respond. You should see no nodes in there, it should be empty, and we are going to start adding nodes here as we go along. Alrighty, so let's start building our cloud. This is our node named Puppet. We're going to do relatively little on that, but on our other nodes, this is my Alice. The first thing I'm going to do now is I'm going to do a quick Puppet agent -- test run just to get this thing to check in on its Puppet host. And again, for those of you who are red-green confused, I'm sorry, I can't really do anything about the green here, but then we don't have any red here. So when we have those guys check in here, there we go. Oh, and of course, for those of you who run Puppet in production, yes, I know this thing actually does auto-signing of certificates. Do not crucify me for that, and don't ever do that in production. Okay? All right. Was that a phone? Ah, too bad. Hang on a second. And then once you have run your Puppet agent -- test one time on all of these boxes, they should actually check in with the dashboard, and you should see them under the node list, checking in as Alice, Bob, and Charlie.example.com. And they're not going to do anything else for the time being. They're just going to check in and are going to show up in the dashboard that way. Yes?
I may be missing something with the config. The VBoxnet 0 for your instructions was 192.168.122.0.
Yes?
Is that right? So where are we setting the 100?
Okay, the question was, as per my instructions, the network address was 192.168.122.0/24. And if you just replace 0 with 1, then it should set that as the host IP address.
Oh, okay.
For
so
that.
check for each of the VBoxnets.
Yeah, exactly. That should do it. Sorry about that. I should have made that more clear in the email. Okay, so this is what we get, and I've prepared a little bit about the OpenStack dashboard here. I've made a few changes here, such as, for example, there is a group in here that's named Kickstack. And for those of you not familiar with how the the Puppet dashboard works here, we can simply define groups, and we can add nodes to groups, and then we can set parameters for that group, and the parameters then also automatically apply to all of the nodes in that group. It's just merely a convenience. In fact, what this thing generates under the hood is just basically YAML that Puppet can then grok. So what we're going to do is we are going to get started with adding our 3 nodes that have just checked in to these boxes. That is Alice, Bob, and Charlie. There we go. And we're just going to add those to the Kickstack group. So we're going to see them. This is not in the node list, but in the group Kickstack. See them here at the bottom where it says nodes for this group. They should now be included there. And once we've done that, there is one minor change that you need to make if you're using VirtualBox that I don't need to make because I use libvirt and KVM. I would ask you to please edit the, and I'm going to get to why we need to do that, but I don't want to run you headfirst into an error. There is a parameter in here that says kickstack cinder lvmpv. That happens to be the physical volume where we are going to create our volume group for OpenStack block storage, aka cinder. For me, that's called dev VDB because I use VirtIO devices. On VirtualBox, those are not available, so I would ask you to change the VDB to SDB because on VirtualBox, they're just named as SCSI devices.
Sorry, Florian, I missed. How did you add the host to the group?
How did I add the hosts to the group? I open the group, kickstack group, and I say edit. And at the bottom, there is a nodes list where I can add them. And the Puppet dashboard does autocomplete. And it will only autocomplete for hosts that have, in fact, checked in with Puppet prior. And then while you're doing that, you can also, in one fell swoop, change this parameter from dev VDB to dev SDB so we can make sure that this actually works on your VirtualBox. Okay. And then what we're going to do is we're going to take our node named Alice here, and we're going to assign a bunch of classes to them. And as you may notice, those classes incidentally map to our node roles here. So there's a few classes that I'm going to add here, actually quite a boatload. I'm going to add the kickstack node infrastructure class. So this creates a database and a RabbitMQ service for me. I'm going to add kickstack node auth, so I get a keystone endpoint and a service catalog and an API service for that. I'm going to add kickstack node API because I want all of the other API services there as well. I want this thing to be an OpenStack controller, so I'm going to add kickstack node controller. I also want this thing to be my dashboard node. And I want it to be my storage node for the time being. I think that should be it. Let me double check here. Yes, that is fine for now. Whoops. Okay, so these are, in total, it should be 6 node roles that you assign to your node named Alice. It should be infrastructure, auth, API, controller, dashboard, and storage. So this thing is going to host all of our API services, our identity service and service catalog. It's going to host the databases and the AMQP service that backs them. It's going to launch and deploy and configure an Apache web server so we can run an OpenStack dashboard, and it's also going to manage our OpenStack persistent storage. So let me repeat that again. Infrastructure, auth, API, controller, dashboard, and storage. 6 node roles in total. And once you do that, you should also see that in the classes list under that specific node, it should say infrastructure, auth, API, controller, dashboard, and storage. And that should be it. And now I'm going to go back to Alice here. And we're going to do a puppet agent -- run interval 10. Just leave that thing chugging along. And it's going to do a lot of work in the background. And if you so choose, you can, of course, follow the tail of var log syslog. And this gets pretty verbose, not super verbose, but you might as well go ahead and keep that running and see what it's doing there. So it does several things. So for example, on Ubuntu, OpenStack packages ship in a separate repository called the Ubuntu Cloud Archive. That is no different on Red Hat, where the separate repo is called RDO, Red Hat Distribution for OpenStack. It will add that to your configuration. It will refresh. It will install the appropriate packages, configure them, et cetera, et cetera. So by the time this has completed, which is going to take about, I guess, 10 or 15 minutes on my box here, we are going to have a nice and configured OpenStack controller, an API node, and a working dashboard, and a few other things that we can then play with. And as you can see here, this chugs along and installs like MySQL client and server and Python packages, and something to generate passwords, and a few other things. So we're just going to let that do its work. And I'm going to stop following the tail here. And while we let that chug, let's discuss this real quick. Okay, so what I'm showing you is one way of deploying OpenStack. If you think that is the one true way, the only possible way that you can deploy OpenStack, you are certainly misguided. Okay, so we have a number of ways of deploying OpenStack using a variety of deployment tools, and I would like to briefly discuss them. There is one interesting project called, and those are essentially alternatives to Kickstack. There's one interesting project called PackStack. PackStack comes largely out of Red Hat. It is based, it's also based on Puppet. It is based, interestingly, on the very same Puppet modules that are hosted and maintained by the community on StackForge that we're also using as target modules for Kickstack. Those modules, as they're being developed on StackForge, have three target platforms: Ubuntu, Debian, and Red Hat, more specifically RDO, the Red Hat distribution for OpenStack. I think that's great. I think it's great that we have one set of Puppet modules that we can use to deploy two different platforms. I think it's a bit strange of Red Hat to then write something on top of that that is RDO specific. Now, obviously, from a business perspective, this makes perfect sense. Anyone from Red Hat here? Yes? So no worries about that at all. But if you're if you're going for an all RHEL or all CentOS setup of OpenStack, this may well be something that suits you really, really well. I have two concerns with it. One is what I just mentioned, namely that it makes no attempt to support other platforms. And the other one is I disagree with the level of granularity that PackStack offers for node roles. I think it is a bit too coarse. What we have in PackStack is essentially controller nodes, compute nodes, and then Swift, proxy, and storage nodes. And I generally tend to prefer a finer granularity where we can actually split between controller nodes and API nodes and dashboard nodes and so forth. But that may just be my personal opinion. Yes?
Would you actually consider PackStack to be production ready? Because I always thought it's in the same arena as DevStack, so essentially for playing around.
Would I consider PackStack to be production ready? This is why I asked whether we have people from Red Hat in the room. So may I deflect the question?
I'm not officially part of the OpenStack team, but PackStack has been used for production environments, but also Foreman has been used for production environments. A lot of what you said can be done with PackStack, should you choose to, in terms of splitting things up. You say about splitting up
Right.
the API.
Okay, so just quickly, just to summarize for the video. Number one, yes, PackStack has been used for production deployments. I'm going to get to the Foreman in a second. Number two, don't quote me on it. Yeah. Is that pretty much what you said? Right? And three, the level of granularity that I like is allegedly actually doable with PackStack. The question is, with what amount of brain surgery on the actual code?
Almost none.
Almost no brain surgery. Okay, so next time you go to hospital, if you get almost no brain surgery, that's...
PackStack produces a also configuration file that you can use to specify how you want to deploy the environment.
Right.
So most of what you can do can be done through that auto configuration file.
Okay. So what PackStack does is it provides or it generates an auto config file that you can then hack through minor brain surgery, and then use that to deploy things. Right, Bruno.
What is the current status of HA on the StackForge Puppet modules?
What is the current status of HA on the StackForge Puppet modules? So far as I know, zip, unfortunately.
That answers a little bit the production question, because if you can run...
I should have put another house rule, which is no religious wars. So what Bruno was saying is essentially if you have something that does not cover HA, then it's not production ready. That is actually one of the more contentious discussions that we are having in the OpenStack community. What is HA? To what extent should you be doing it? To what extent should you be supporting it? There will be plenty of people that you can talk to that look at something that the Puppet modules do, and that will qualify as HA by their definition for their workloads. But like I said, let's please not get into that religious discussion.
Just to know what you're saying, I'm not saying it's not production ready. I'm saying you need to judge if you can run an OpenStack environment without that level of...
Right. So what Bruno was saying is you need to judge whether you can actually, whether it makes sense for you to run an OpenStack cloud without HA. I will be even a little more careful in wording that, and I'll say you need to judge whether your OpenStack cloud manages to achieve your definition of high availability that you need for your specific setup. But that being said, by all means, please take a look at PackStack. If that makes great sense for you, use it. Another project, Crowbar. Now, Crowbar comes out of Dell. All of these slides here that I use were meant to be PG rated and suitable for children. This is an exception because the official mascot and logo for Crowbar is this scary purple bunny wearing or carrying a makeshift melee weapon, which will undoubtedly frighten small children. But that's actually what it is. They put this stuff on golf shirts. Crowbar is a project, like I said, that comes out of Dell and is also the deployment platform of choice for SUSE Cloud. So SUSE Cloud is an OpenStack-based private and hybrid cloud product that comes out of SUSE. By the way, any SUSE folks here? Yes? And it uses Crowbar as its deployment mechanism in conjunction with Chef. So the other Ruby-based automatic deployment and configuration management utility. And I think, I'm purely speculating here, but I think that is the reason why the Puppet stuff on StackForge never made any attempt to support SUSE. Because apparently there was no input on that side because SUSE seems to be very much Chef-centric here. Scary mascot or not. I wonder what happened if you used a Geeko Chameleon and gave it a crowbar.
I've got a picture of that.
Oh, really? Okay.
But not for children.
Yeah, like I said, it's definitely R-rated. Okay, then there's Juju. Juju comes out of Canonical. Now, Juju, I think, is a very, very interesting project. What Juju attempts to do is the Canonical folks call this DevOps distilled. So you can crowdsource what they call Juju charms, which are essentially sort of little deployment Lego bricks, building blocks. And all of Juju is interestingly controlled through a single YAML file. And Juju comes with a GUI that you can use to graphically place your charms and the relationships between them, and it will then generate that YAML file for you. And then you can easily share that with someone else. So the proposition there is kind of really cool. It's like you have essentially an electronic whiteboard where you're placing all of your little bits and pieces, and then that generates a YAML, and then you toss that onto your Ubuntu OS installed nodes, and boom, suddenly they become an OpenStack cloud. That's really kind of cool. Again, there's a bit of criticism about Juju, sort of in reverse of what is true for PackStack, namely that it seems to be largely Ubuntu-centric for the time being. So if you're sort of a mixed shop that runs both Ubuntu and RHEL/CentOS, then you might be less happy with Juju than you would like to be. That being said, it's not entirely set in stone that that will always be that way. And in all fairness, we should also say it's probably not set in stone for PackStack to always be purely Red Hat-centric. So we'll see what the future holds there. But this is another thing that is sort of an interesting way of deploying OpenStack based on, for the time being, Ubuntu. And then there's OOO and Tuskar. And Michael, do we actually have a logo for OOO and Tuskar? Do you know? Is there one?
You're asking this, Michael, right?
What?
You're asking me,
Yeah.
Not that I'm aware of.
Because I'm not actually seeing any OOO folks in here. So no, right? So OOO stands for OpenStack on OpenStack. And OOO is a bit of a brain twister, which is you're using the OpenStack scheduling and deployment mechanisms not for deploying virtual machines on a cloud infrastructure, but for actually deploying hardware. As in, you are not firing up a virtual machine through a hypervisor with an image, but you're firing up a piece of hardware through PXE and IPMI, and then you're streaming an image to it. And then you can manage that thing as if it were a virtual machine. Yeah? And OOO was largely driven originally by the folks from HP Cloud Services. And what they actually do is they run, in their public cloud, is they run 2 levels of OpenStack. They run what they call the undercloud. That is stuff where OpenStack is only used to manage hardware. And then within that undercloud, they use OpenStack to deploy OpenStack control nodes. And within those OpenStack control nodes, using 2 levels of virtualization, you can then run your virtual workloads. Rackspace had a cooler term for this. They called it Inception, and they did it before then. But OOO, in conjunction with Tuskar, which is an effort driven primarily by Red Hat, and they merged pretty much this summer, if I recall correctly. This aims to be sort of the OpenStack deployment initiative. Whether or not you agree with that is essentially up to you. Some people think this is a wonderful and great idea to basically do everything with OpenStack. Some people think not, and they prefer to deploy their physical infrastructure basically the old way, using things like PXE boot and whatnot, and then just manage virtual workloads with OpenStack. Like I said, you essentially have both options. Oh, and another thing that I should mention, because we heard it earlier, the foreman. I know Glenn is very familiar with the foreman. Who else knows the foreman? Okay, quite a few. So the foreman is essentially, well, Puppet on steroids, pretty much. So it builds a whole lot of bare metal infrastructure management around Puppet. Kickstack, by the way, you can absolutely use with the foreman, because the foreman also acts as an ENC, an external node classifier for Puppet. So the node role assignments that we're doing with the Puppet dashboard, you might just as well be doing with the foreman. So you can do that as well. Okay. Oh, and another thing that I should have mentioned when I was talking about Crowbar was you can also arguably deploy OpenStack with pure Chef, although in my humble opinion, the support for that and the community involvement is not nearly as far as the Puppet stuff. to an extent driven by one really, really large OpenStack user, which is CERN, the European Organization for Nuclear Research, which has been running an OpenStack cloud of in excess of, I think, 10,000 nodes. What is that?
15,000.
Well, yes, indeed. 15,000 happens to be in excess of 10,000. And they're actually doing a lot of work in OpenStack, and they deserve a certain amount of compliments for that. Not only the Puppet integration, but also things like Active Directory integration and a few other things that they have been doing. Okay, so while we're done with that, while we're done with the listing here, the question, should I use one or should I use the other? The answer for that is obviously yes. Which one is best suitable for you is entirely up to you, or is essentially defined by your requirements, your SLA, your customer needs, etc. But by all means, you should be deploying OpenStack. I will say that by my clearly biased opinion.
Florian,
Yes.
have you had much experience with the OOS stuff yourself? How did it go?
No. Oops, sorry. Where's my Alice? Here's my Alice. There we go.
On the OOS question,
Yeah.
it kind of depends which bit you're asking about. Devananda,
Oops.
project technical lead for the hardware deployment stuff, is here at this conference.
Yes, indeed.
My take on it is it's not production ready yet. They're still dealing with bugs. But they are ready enough that they are developing. They have a CI process where they deploy real physical clouds over and over again in a loop, so they know when it breaks and stuff. But say Robert Collins or Devananda would have a better feel for it. It would be a thing you should do.
So I'm not going to repeat all of that for the video, but Michael was saying that we have both Devananda van der Veen and Robert Collins here at the conference, who are both very, very deeply involved in this. And by all means, if you want to know more about OOO or Ironic or the bare metal drivers for Nova, etc., you should by all means talk to them.
Florian, just
Yes.
completely a side question.
Yes.
What is your presentation called?
I somehow anticipated that question. My presentation toolbox is a combination of Reveal.js, which is a JavaScript-based in-browser HTML canvas presentation thingy that you should totally check out because it's freaking awesome. And what I use for the terminal here is Shell in a Box, which is an Ajax JavaScript terminal emulator that I just display in an iframe inside the Reveal.js thing. Okay, so my box happens to be a little bit slow today, so this is not really fully completed yet, but we're just going to leave it running. But we should already see a few things that have happened here, such as, for example, one of the things that Kickstack does for us is as it creates an infrastructure that, for example, includes our database. So there's a few Cinder and Keystone and Nova and Glance and Heat databases that it has prepared for us here. It has also configured a few OpenStack services. So there's Nova Console Auth, but I actually wanted to show you Keystone. Where's my Keystone here? So my Keystone is running here, and it happens to be netstat lntp. What is that? 14672. And it happens to be running on ports 5000 and 35357. And what Kickstack also generates for us is an admin user generates a password for that admin user, and it handily puts it into this little OpenStack RC file, which we can now source. And we can then do, for example, a Keystone endpoint list, where we should hopefully, while this is dying of I/O, there we go, while this thing is dying of I/O, we should see a list of OpenStack endpoints that have been configured here. And of course, you know, because this uses a relatively large font, it wraps around terribly. But we could, for example, do a, where are we at? Service list. So these are the endpoints for which, these are the services for which endpoints are currently defined. We have the Keystone service itself, that's our identity service that's running here. We have the API services for Nova, that's the OpenStack compute layer. We've got Glance, which is the image service, Cinder, which is the block storage / volume service. We have Neutron, which is the networking service. And we also have a variety of other services that are running there. And in fact, maybe, if we're lucky, we already have an OpenStack dashboard. So let's take a quick look here. And again, if you're, there we go, 192, 111. Sweet, there's Horizon. And we can now, this is great. Reveal.js, by the way, has VI-style shortcuts for moving around, if you like those. And I just ran into one of those. So that's my auto-created password. And I'm going to log in here as admin and hoping for no demo effect. No. See? That's what I told you. Oh, wait, maybe my Apache has just been restarting due to a Puppet run. Sorry about that. Let's see. That guy is going. Finish catalog run. Okay, that looks good. Let's do that again. What is that? That looks better. That looks much nicer. And one thing that I'd like you to understand is that we actually haven't done anything with our compute nodes and our network nodes here, but we already have a full set of API services for OpenStack. And because of that, because we have all of these API endpoints available and responding and whatnot, we can already sort of play with the OpenStack dashboard here. So hang on one second. Let me just kill my Puppet here, because I'm a little short on resources on this thing, and we're not going to need it anymore here. What is that? 1482. Yeah. Come on, it's going to go away eventually, I hope. Yeah, kill it with fire. Come on. Ah, there we go. Nope. Come on. Now it's gone. Didn't want to kill that bugger. So let's see if we're good here. Okay, that's nice. All right, so what I wanted to say is that we have all of our API services, so therefore our dashboard is available. Therefore, we can also interact with our OpenStack services using the CLI tools and, of course, the JSON API tools, etc. And we're going to start doing that in a moment. But why not start the configuration of our compute node and our network node in the interim? Yeah, I just killed Puppet, so that's red. So we're going to add the Kickstack node compute class to Bob here. Kickstack node compute to Bob. Where's my Bob? See, V and P. Puppet. There we go. So there's that. And look. Okay, that's running. Oh, by the way, this is something I should mention while I see it here. It is no accident that this says starting Puppet client version 3.3.2. Unfortunately, the Puppet StackForge Puppet modules currently do not yet work with Puppet 3.4.0 because Puppet 3.4.0 removed a quote-unquote feature that was available in all of the Puppet versions up to that version, which was never documented, and therefore they just killed it sort of at the last second and then left people sort of in the rain. And the Puppet modules on StackForge haven't fully caught up with that yet. So if you want to deploy this, use Puppet 3.3 and you'll be fine. For now, and then everything should be fine again in a week or two. Okay. All right, so that fetches a bunch of info. And then, Okay, so that's going to be our compute node, and then we're going to have Charlie. Charlie is going to be our network node. Network. Here we go. Okay.
So what did you add to Charlie?
Network. Just network. And now this also runs a bunch of MySQL client installations so we can talk to the database and Nova and a few other things. And while that is running, and on your machines, if you have a lot of RAM, you can probably kick them off for Bob and Charlie simultaneously. I'm going to do it serially because otherwise my machine is probably going to croak from acute I/O. Because while we're doing that, we can already play around with not only the dashboard, but also with the CLI tools. Now, if you want to interact with OpenStack through the CLI tools, you're going to have to, what the hell? There we go. You're going to have to source the OpenStack RC file. I just did that earlier, but I can do it again. OpenStack RC. All of the OpenStack command line clients essentially use a unified interface. They all support pretty much the same, well, they all support a specific set of options and arguments, and then they all, of course, have service-specific ones. And this includes the way that we set information like what's my username, what's my tenant, what's my password, what's my authentication endpoint. I should mention what a tenant is. OpenStack is fundamentally a multi-tenant system. That means that you can logically segment your cloud into areas that are only known and seen by people in or users in that tenant. And that includes not only the users themselves, but also your virtual machines, your virtual networks, your images, etc., etc. And that means that your cloud is entirely logically segmented while it's, of course, running on shared physical hardware. Although, of course, you want to take into account Matthew's comments from the keynote this morning in terms of security. So, for example, we could, hang on a second. We could use Neutron to interact with our list of networks, which at this point is going to return an empty list, or so I hope. Apparently, even SSDs are not as fast as they used to be. So this is not very exciting, but this is what I expected to see here. No errors, but an empty list that's being reported. And even though we don't yet have any infrastructure to implement it, because we don't even have a network node at this point, we can already create a set of networks. And I could do this through the OpenStack dashboard, but I can also do it in a scripted fashion. And I've put a little script in there on your nodes called create neutron networks. And if I run that, it's just going to create a few logical networks for me. Slowly but surely. There we go. And let's take a look at what that means, because we have in our project panel over here in the OpenStack dashboard, We have something that makes us wait, but it's going to be here in a moment. We have this thing called network topology. And we get a nice little overview of the network topology that we've just created. So with that little script, I created two networks. One's called AdminNet, and it uses a private IP range, 10550/24. And then I have the ostensibly external network. Now in a production setup, this would most likely be not an RFC 1918 address that you see here, but an actual public IP segment. In this case, I've just declared 192.168.144.0/24 to be my external network. And then I have a virtual router between them. So we can actually route traffic through those. And I can do this in a pretty much arbitrarily complex fashion in OpenStack. I can define as many networks as I want, routers as I want. I can connect them as I wish. And as we're going to see in a moment, I can then also plug, of course, virtual machines into the networks I like. I can do that by interacting with the Neutron APIs directly. I can also do it in an orchestrated fashion through Heat, where I can have a template that in one fell swoop defines a whole set of resources, including a set of networks for me. In the recent OpenStack release Havana that dropped in October, we've got a number of exciting and interesting new features, specifically in the network stack. In OpenStack, we now have facilities to manage firewall as a service, load balancer as a service, and VPN as a service, all of which is really, really cool. And I should also mention, for those of you who are new to OpenStack, is that there are a variety of ways that this network topology can be implemented. As we're going to see in a moment, what we're using here is we're actually building an encapsulated, segmented Open vSwitch network. But you can, for example, interact with a number of hardware and software switches that support OpenFlow. You can interact with a bunch of hardware from the likes of Cisco and Juniper and what have you. And you can use OpenStack Neutron to actually build a fully software-defined network, meaning a network where the data plane, the thing that is concerned with actually forwarding frames and packets, and the control plane, the thing that defines how these packets should be and frames should be forwarded and routed, are completely separate, and only the data plane is the stuff that actually remains in the firmware of your switches, and the entire control plane moves into your servers, which when you think about it is a really, really, really cool architecture. So that's my network topology here. So let's see how else we're doing. Where's my Bob? That has already started an iSCSI daemon. That sounds and looks good. Let's take a look. It hasn't done the Open vSwitch bits yet. Okay, so it's probably going to do that in a second. Okay, that's still installing libvirt and whatnot. So that is going to take a few extra moments. And that is Neutron config. That looks good. And in about 10 minutes, we should have the cloud in a stage where we can actually fire up virtual machines, which will be fun. Actually, in the interim, we can do a few things with it. So for example, we already have an OpenStack image service. Let's see. Where's my image? Oh, come on. Was that a phone? I should extend that to whenever any electronic device makes any sound, you owe me a drink. Okay. So we're going to upload a Cirrus image here, and this was also on the USB drive. For those of you who are not familiar with Cirrus, Cirrus is a really, really, really tiny cloud image that you can use really, really well for testing purposes like that. It is a really, really small operating system install. That's only 13.1 megabytes in size total. And pretty much the only thing that it can really do is it can talk to Cloud Init and configure itself that way. So for those of you familiar with AWS, I'm sure you're also familiar with Cloud Init. Cloud Init is that little thing where a booting virtual machine connects via a magic IP address to a RESTful EC2 metadata service and then configures the machine accordingly. OpenStack does the same thing through OpenStack Nova. So it can basically grok the same kind of configuration method, and Cirrus knows how to do that. That's pretty much the only thing that's special about it, other than the fact that it's really, really tiny and therefore is really easy to distribute. So we're going to create a new image called Cirrus. We're going to select the image source image file, and the format is, and it's going to be the Cirrus 031 x86 disk.image that was also on the mirror. And then we are going to create this bugger. There's my Cirrus image. Again, if you want to just walk through this, this is in the OpenStack dashboard under Project, Images and Snapshots. There's a little plus button up here that says Create Image, and then you need to select a name for it. You can optionally add an additional description field. You can either pull your image from any URL on the web that the machine has access to, which can be helpful, or you can just upload a file through your browser. In this case, I chose to upload a file through a browser. And unfortunately, it doesn't do auto detection of the image format, so you actually do need to set that. However, this also shows you that the OpenStack image service glance actually groks a large variety of image formats. Here we're using a QCOW2 image format, as is being used by QEMU and KVM. You can also upload a raw image. You can upload an ISO that you can boot from. There are a variety of Amazon-related images that OpenStack can work with, and it also groks VMDKs, so VMware images, and the VDI and VHD image formats. The VHD image format is the one that is used by Microsoft Hyper-V. So there's a number of images that you can, image types that you can use and upload. How are we doing here? Okay, that looks much nicer. And what we should see now is this thing has already configured its half of an Open vSwitch configuration. This is not very spectacular for now, but it is going to get much nicer when we see our Puppet agent run interval. When we're going to see the same thing happen on Charlie. Let's see. There we go. And then once that is completed, we're going to see the other half of that tunnel also configured automatically. What am I doing? There we go. Okay, so while that is running, and it should take another few minutes, I am going to add a few more things to my configuration. So one thing that the AWS users among you may be familiar with is the concept of flavors. So you want to be able to define how large specific virtual machines should be, how much CPUs, virtual CPUs they should get allocated, how much RAM, how much disk space, and that concept of flavors we also have in OpenStack. So under the admin system panel, there is this little thing here called flavors, and by default it sets up 5 flavors in total: the tiny, small, medium, large, and X-large flavors. purely coincidental that this sounds kind of like what you would find on AWS. And I'm going to create a new flavor here that I like to always create, like for testing purposes. I'm going to call it M1 Nano. Just one vCPU and a meager 256 mega RAM. And the whole ephemeral disk, swap disk, blah, that all goes to 0. And we're going to create that flavor. Come on, there's my M1 Nano flavor. This is probably going to be much faster on your boxes, but that's a nice theory. I'm sure that your box was way more expensive than mine, so it must be better. It also has a shiny apple on it. Oh, and what else do I want to do? I generally want to be able to SSH into my machines. You know, that would be kind of nice. So because I want to do that, and I also want to be able to use my standard SSH identity for it, I'm going to upload my SSH public key into the system, which I can do from project, manage compute, access, and security. We can define security groups, which are essentially sort of a poor man's firewall as a service. And we can also, what we're going to do here is we can either create or import SSH key pairs. I'm going to choose to import mine. So, whoops, where's that? Where did my Alice go? Ah, come on. What the hell? Ah, here. Here's my Alice. Oh no, this is slow as hell. Bear with me. There is my Alice. Okay. And we're going to do SSH-L. Oops, not SSH. Add -L, of course. So that's my SSH identity, which I can now cut and paste. Import key pair. That's my public key. Let's see. That looks good. And I'm going to call that Florian. Sweet. OK. I have my key pair in there, and I have almost everything that I need to fire up a VM. So let's check how our Charlie is doing here. Get in there. Do we have an open vSwitch here yet? Nope. Ah, it's going to get there. We're almost good to go now. But if I were firing up a virtual machine now, since I don't yet have a DHCP agent and a metadata forwarding agent running on Charlie, it would come up, but then it wouldn't get a network configuration, which would be kind of boring. So let's just wait another few minutes, and then we should actually be able to do that. Because other than that, we're essentially all set. Oh, look, open vSwitch data path. Oh yeah, this is another thing that I maybe should mention. I'm actually kind of sad that Simon Horman appears to not be at LCA this year because he's an excellent Open vSwitch person. The Open vSwitch data path module was merged into the mainline kernel in I think the 3.3 version, and Ubuntu, the last Ubuntu LTS shipped with a 3.2 kernel. So they're shipping it as a separate DKMS module that you actually have to deploy onto your boxes, which is a little, well, inconvenient, thank you. That was the word I was looking for. So what it will do is if you install Open vSwitch, it will actually get the Open vSwitch data path DKMS modules for you and then compile them in place. Oh, cool. There we go. OVS, PS. CTL. Show just a second. And We have a tunnel. Oh. Who had a question? Yes? Oh, hi, Simon. So what this does for us is it reduces or it completely removes a load of complexity for us. What this has created is it has created a GRE tunneled virtual network inside Open vSwitch, which is kind of cool because if we have more compute nodes and a network node, then what OpenStack Neutron will do for us in this case, it would actually create a full mesh of these GRE tunnels. So that means whenever I fire up a new virtual machine, no matter what hypervisor it runs on, what hypervisor node, what compute node it runs on, it has this gigantic virtual switch with potentially thousands of ports that it can plug into, which is like completely removed from the physical network infrastructure, which is really kind of neat. I should mention that GRE has some scalability issues, but it is not the only encapsulation method that Neutron supports. Within the Open vSwitch framework, we can also support VLAN and VXLAN for segmentation. And GRE is just kind of nice because it's like simple, relatively simple to set up and run and use. Here we go. I'm not going to get into too much detail, but if you're a network geek, you're really going to like what the specifically a Linux networking geek, you're really going to like what the OpenStack Neutron agents are doing on the network node for DHCP and L3 routing services. They use network namespaces in a pretty clever way, which is really cool, and I encourage you to get into that in a little more detail if you are interested in networking at all. It's a really, really neat little implementation there. And that's why, for example, we see these network namespaces here and funny things like IP addresses that only exist in specific namespaces, and IP tables rules that only exist in a namespace, and all this other cool stuff. Because what this enables us to do is we can have multiple tenant networks with completely overlapping IP ranges. So we can have, if you're running a public cloud, you're now at liberty of telling your customers, for your private networks, you can use whatever IP addresses you might ever want, because you're not going to tread on someone else's toes, because if there's a different tenant that uses networks with exactly the same IP addresses, that's totally cool. So that's perfectly fine, and they will still be able to map to public IP addresses and all sorts of other things. So it's really pretty neat under the covers. Okay, so let's finally do something with this. We have an image. And now we're going to launch it. So we are going to name that instance test because, again, I may have mentioned this before, I'm ridiculously creative. We only want one instance of these. We're going to boot them from an image, namely the Cirrus image that we have just uploaded. I want to make sure that I'm able to SSH into this box using my key pair that I previously uploaded, which is what I can do through the Access and Security tab. I want to make sure it is plugged into the admin in network, and then we should be good to go. So what is happening in the background here is this node is first being scheduled. That is to say, I'm sorry, this VM, this guest is first being scheduled. That is to say, Nova, specifically the Nova scheduler service, selects an appropriate hypervisor host, an appropriate compute host, and we can influence that placement by a variety of factors. So there is a number of scheduler algorithms and scheduler filters that are available. We can pass scheduler hints or filter hints. So we can say, for example, these two virtual machines should be running on the same box, physical box, or should not be running on the same physical box, for example, for HA purposes. What then happens once the guest has been scheduled for a specific Nova compute service, it is spawned there, which means the image is fetched from glance from the OpenStack image service is then placed in a local cache, and then we create a new virtual machine off of that image. That virtual machine is then fired up, so it basically becomes part of the virtual machine management infrastructure there. In this case, that's libvirt. And it also gets an IP address, which we should now see in the log here, I hope at least. There we go. That's actually a complete boot. That was faster than I thought. The Cirrus VM here boots with a micro DHCP client. It basically sends a discover. It then gets the 10553 address, which Neutron has allocated for it. Then it does this. I don't know if you can see this properly on the screen, considering the font. Maybe I can zoom in here a little bit. Those of you who know AWS will be very familiar with this type of URL. It's an HTTP request to a magic IP address 169.254, 169.254, and it then grabs that information from, in this case, the Nova Metadata API service. In this case, that actually took 2 tries, and based on that, it is properly being configured, etc. It's also being configured for SSH access with the key pair that I have previously defined. And what I can now do with this instance is this now has a tenant network IP address, 10553, which means that it can talk with the outside world. It can also talk and is accessible from all other nodes in that same network, but it is currently not accessible inbound from the outside world itself. So let's fix that real quick. We're going to associate a floating IP address here. We're going to allocate one from our pool in the external network. And then we're going to assign it to 144.101 to that machine. So that has now been associated. And let's see. Ta-da-da-da. Oops. Where is that? There we go. There it is. And that's my little Cirrus virtual machine. There we go. And I wanted this actually. Do we have a Monty here? Oh, we don't. Cool. What is that? Here we go. So this is the IP address that we got here from Nova. And wait a minute, should this work? It actually should work theoretically. I hope so, at least. Nope. Oh yeah, of course, if I turn off my own network, then that's not going to work. Never mind. So that was, well, we started an hour and a half ago with like a totally blank Ubuntu, and with lots of talking in between and a slow box and Puppet and whatnot. We're up and we've got a cloud that can actually do stuff. So for example, we might, what might we do? We might, for example, assign this thing, let's see, oops, I didn't want to do that. We want to assign this thing persistent storage. How about that? So we're going to create a volume. We're going to name that test vol. And we're going to make it, whatever, 1 gig in size. Create the volume. And there's the volume. Partitions. What the hell? There we go. So there's only one virtual device here at this time. And now, how about we attach that to test as dev VDB. attached. And lo and behold, there it is. And what's kind of cool here, again, is that this is completely decoupled from the underlying storage technology. What we have here is, in fact, it's an iSCSI-based system. So what we're seeing here on Alice, which we defined as our storage node, is there's been a logical volume that has been auto-created for us with a size of 1 gigabyte, and that is then being exported via iSCSI using TGT, and that's the backing store path here. And then on our node named Bob, that suddenly shows up as a SCSI device. That's the little virtual disk here. So what it does on the compute node is it appropriately configures an iSCSI initiator and then makes that available to the hypervisor using whatever interface is appropriate. And in this case, that's just virt.io. And it could also do SCSI and whatever. And again, this is completely decoupled from the underlying technology. So what we're doing here with LVM and iSCSI, we can do with exactly the same clicks in the dashboard if our underlying storage is, for example, Ceph, and then we'll create a Ceph RBD volume and configure Ceph RBD, the Ceph RBD client on the, well, actually the QEMU storage driver on the compute node to talk to it. And again, it's just going to look like DevVDB. If we're talking to HP 3PAR or Left Hand or an EMC device or whatever, then it's going to do the exact same thing. It's the exact same click. Or I could, of course, also have done this from the command line, just like you can do a Cinder list here that shows me this newly created volume. I can also do a Cinder create, a Nova volume attach, et cetera, et cetera. And it's completely decoupled from the underlying infrastructure, which when you think about it is really cool when you consider that this is also true for network, it's also true for computing, for your hypervisor management, etc., etc., etc. So in other words, OpenStack equals awesome. But again, like I said, my opinion here is clearly biased. If you happen to like this talk, as we are just about out of time, and I do want to take 5 minutes for questions. If you like this talk, please be informed that it is freely available under a Creative Commons license. Note that there is a fine print down here because obviously that does not apply to trademarked logos that have been used in this talk. But if you want to use the rest of this talk with the same disclaimers, please by all means feel free to do so. You will find the sources for the slides here. All of that is on GitHub. github.com/fghaas/LCA2014. So if you want to snap that now, by all means, feel free to do so. And you can also see these slides that I used, like rendered from here. That's stexo.com/LCA2014. And then, of course, these slides have also been made available to the conference organizers. So feel free to check the wiki or wherever they're putting that up. OK, and let me check here whether we have any questions here on the event. Oh, this is a fine time for the Wi-Fi to break. Ah, here we are. What steps would have to be taken to turn the storage for these, to make the storage for these guests highly available, and also what steps would need to be taken to make this OpenStack setup highly available? Okay, I'm going to punt on the second question because that's just going to take a little more time than 5 minutes to explain how we make all of this highly available. But when we talk about storage that's highly available, you just saw that. If our storage backend, our Cinder backend, is highly available, and Ceph, for example, is an example for a highly available, highly distributed, highly resilient storage backend, and it is fully integrated with OpenStack Cinder. then if you choose not to boot your virtual machines from an image, but from a volume, which is also something that you can absolutely do, then the entire virtual machine becomes persistent, and so does all of the data that you write onto that thing. So that would be sort of the standard stepping stone for VM high availability. And I should set up an OpenStack cluster each year at LCA to make everyone's demos faster and more reliable. Okay, I'll be happy to do that. That is conditional on me actually being here, which I would absolutely love to do, as I have done for the last few years. So thank you for that suggestion. Okay, and with that, I'm going to open the floor for more questions. We have another 5 minutes, and I don't want to keep you any longer because I'm sure you're hungry. Yes?
What do you do in the situation where Horizon just gives you error when it tries to run a VM? Because there doesn't seem to be much like feedback.
What do I do when Horizon just gives me error when I'm launching a new virtual machine? The first is I approach my coffee machine and get a cappuccino. Now, I presume that your question is really how do I troubleshoot virtual machine launch errors. And it is one of the commonly leveled criticisms against OpenStack that you have to have a fairly good understanding of the architecture to be able to effectively troubleshoot. Generally speaking, you would first check the Nova API logs. Is there an error that has been flagged by the Nova API service? 2, if you don't see any errors there, check the scheduler, because something that is very, very common is for a virtual machine to get to the error state because the scheduler has not found a suitable host for actually scheduling your VM, because all of the available ones were out of memory or none responded or whatever. Once you have been able to determine through the scheduler, you can also do that with a Nova list or a Nova show, which host has been selected for firing up this virtual machine, take a look at the logs for Nova Compute on that host. And with those steps, in 99.9% of cases, you're going to have you're going to find an error message that explains to you relatively clearly what's actually going on. In the very, very rare case that doesn't help you, then it basically goes into the, for example, into hypervisor-specific troubleshooting, where you might look at your libvirt logs or at your KVM monitor output or whatever. So it's a defined process, but you need to understand the architecture and the API call flow to actually make sense and make use of that. I saw several other hands. What is that? Sorry? Sure.
So step 0 is determine the instance UUID. Everything in the logs is going to be by instance UUID, so that's what you're going to grab on. And that wasn't true for older, like say, assets. So -1, run something modern. 0, determine the instance UUID. The instance fault table in the database is also useful because it will show you the stack trace Nova thought was the reason the instance died.
And you can also retrieve that via a Nova command line command that just escapes me.
Yeah, so
Something,
yeah.
yeah.
Call to get to it, etc., right? But that you could also do roll-up reports and say what are the instances of exceptions that are causing me to fail to start instances, for example.
The other thing to check, especially if you're using KVM, is to make sure that the flavor that you've used has enough RAM to run the KVM instance to
Right, yes. So flavor mismatch, like for example, you want to fire up a virtual machine with a flavor that is set to define 500 gigs of storage. I kid you not, I've seen that. And then no compute node actually having that kind of storage available. That would be one way where the scheduler would fail and say, hey, I can't schedule this thing because the resources are just unavailable. Okay, one other thing that I do want to say, shameless self-plug, if you're interested in training about this stuff, do check out academy.hostexo.com. And I will be around until tomorrow night. I'm not flying out until Saturday. So if you have any questions about this, I'll be more than happy to answer them. Like I said, you can follow me and find me on Google+. That's an easy way to get a hold of me, and I'll be happy to chat. I also have a stack of business cards with me if you want to talk further after the conference. thank you very, very much for coming this morning. Thank you very much for your attention. Thank you for your questions. Thank you for having me here at LCA again, because it's awesome. And enjoy your lunch and have a great afternoon. Thank you.